We are going to do chapter 10 today. These are the answers for today's questions. Questions 1. Calculate the wavelength of the following. A photon with energy 3 eV. B. An electron with kinetic energy 3 eV. C. A proton with kinetic energy 3 eV. So questions A to determine the wavelength for a photon, and you are given the energy. So let's apply the equations for energy for photon, which is E equals to hc over lambda. Substitute the values into the equations and you will get lambda equals to 4.14 times 10 to the power of negative 7 meter. Now, some of you might have curious, why am I using 3 times 1.6 times 10 to the power of negative 19 here? In fact, question just give you 3 eV. Well, that is because when you apply equations E equals to hc over lambda, E need to be in terms of joule. Why? Because joule is SI unit, but EV is not. Questions B is asking for the wavelength of an electron. Now, can we still use the equations E equals to hc over lambda to determine the wavelength? The answer is no. Why? Now, that is because electron, it does not move at the speed of light. And in equation E equals to hc over lambda, we substitute C equals to 3 times 10 to the power of 8, which is the speed of light. Therefore, these equations cannot be used to determine the wavelength. Then what is the equation should we use? Try to look at the list of formula. To go through the list of formula again, now you will see that wavelength of an electron can be determined by using lambda equals to h over 2 MeV, where this eV, it represents the kinetic energy of the electron. So substitute the values into the equations, you will then obtain wavelength equals to 7.03 times 10 to the negative 10. So once again, for EV, I substitute it as 3 times 1.6 times 10 to the power of negative 19 because the kinetic energy must be in joule when it comes to the substitution. Question C is asking for the wavelength of proton. Now, since proton, it does not move at the speed of light again, therefore, we are going to use lambda equals to h over square root 2 MeV to determine its wavelength. The difference between proton and electron is in terms of the mass. So you need to get the values of the mass, list of constant. So substitute the values into the equations. You will then obtain lambda is equals to 1.65 times 10 to the power of negative 11 meter. Now, since we use lambda equals to h over 2 MeV to calculate the wavelengths for electrons and also for a proton, can we use these equations to calculate the wavelength for a photon? Again, the answer is no, because photon is massless. We don't have the value for the mass. Questions 2. The wavelength used in an electron microscope is 2.5 times 10 to the power of negative 11 meter. What is the speed of the electrons? What is the kinetic energy of the electrons? And if a photon is used, what is the photon energy? Since you are given wavelength, the speed of the electron, let's just apply the de Broglie equations. So given lambda equals to h of p, and p is the momentum, which is equals to mv, therefore lambda is equals to h over m. Substitute the values into the equations, you will then obtain v equals to 2.91 times 10 to the power of 7 meter per second. Questions B is asking for the kinetic energy of the electron. So this is just a very simple question. You can solve it by applying the equations K equals to 1 over 2 mv squared. Substitute the values into the equations. The kinetic energy is then equals to 3.86 times 10 to the power of negative 16 joule. Question C asks you to calculate the energy if now you replace the electron with photon. So for photon, can you still use the equations K equals to half mv squared? Once again, the answer is no, because it is massless. So the equation should be used in this question is E equals to hc over lambda. So substitute the values into the equations, you will obtain energy equals to 7.96 times 10 to the power of negative 15 joule. So that's all for today. I will see you again tomorrow.